Everyone, welcome back to Logic Binder. In this video, we will learn about the Lex tool, which is an important utility used in compiler design. What is a Lex tool? Lex stands for Lexical Analyzer Generator, and which is used for the specification of the tokens. As we know, writing a lexical analyzer manually can be time consuming and complex. To simplify this task, we will use the Lex tool. The input to the Lex tool is a Lex language, which contains patterns and actions for recognizing the tokens. The tool itself acts like a compiler that generates a lexical analyzer automatically. How the Lex tool works in the background. This tool converts the specific patterns into a transition diagram or finite automata. Based on these patterns, it generates a C source file called lex.yy.c. This file contains the code for the lexical analyzer. The generated C program can then be compiled using a C compiler, which produces the executable or object code for the scanner. In the diagram, you can see here, the input given to the Lex compiler is a Lex program which is saved using extension .l, and this is converted to a C program called lex.yy.c using the Lex compiler, and then this generated C program is given to the C compiler, which gives an executable file named a.out, and to this a.out you are going to give the source program which is written in the higher level language to get the stream of tokens. Structure of Lex program. It is divided into three parts: declarations, transition rules, auxiliary functions. These three parts are separated by the symbol %. Now we shall discuss every section in detail. First section is declaration section. This section contains variable declarations, identifier declarations, regular definitions, header files, constants, and macros. In simple words, all information needed before pattern matching begins is placed in this section. Second section is translation rules. This is the most important part of the Lex program. In this section, we write a set of pattern and action pair. The general form is pattern followed by action within the curly braces. The pattern specifies what to search for in the input. The action specifies what should happen when that pattern is found. For example, 0 to 9 plus followed by the action printf number found. Here, what is the pattern? It matches one or more digits, and the action prints a message whenever a number is detected. Thus, the lexical analyzer continuously scans the input, executes the corresponding action whenever a pattern matches. The third one is auxiliary function section. It contains user-defined functions that support the lexical analyzer. These functions may be used for installing identifiers into the symbol table, storing constant, performing additional processing, and any handling of special cases. In short, any helper functions required by the scanner are written in this section. If I ask you how a lexical analyzer is designed, just mention these steps. Okay. The first step here involved is define the token patterns using regular expressions, and then convert these regular expressions to finite automata. Next, optimize the generated automata. Generate scanner code from the automata. Finally, use the generated scanner in the compiler. See a sample program which recognizes keywords, numbers, and words in a given string. Here, this is the declaration part, which is having only the standard C header. This standard C header is written between these two symbols, and then followed by %, Means this is the second section where you define the patterns and followed by the actions. If you are encountering if or else, what am I doing? Consider them as keywords. If numbers are encountered, print them as number. If words are encountered, print them as words. These are the patterns and actions. Auxiliary function, here we are using main function where we will enter the string and read the string using YYLex function. You can see here YYText is used. It is a built-in lex variable holding the current matched lexeme. Coming to YYLex, it is a function generated by the Lex tool that performs the lexical analysis.